Good afternoon, everybody. Welcome to today's OCTIO Gratitude webinar. My name is Rajan, Vice President Sales and Commercial at OCTIO Gratitude, and it's a pleasure to have you today. Today's webinar is mainly focused on Drillwatch technology introduction and potential applications and value proposition for our customers. During this unprecedented COVID-19 period, most of our customers continue working from home, and most of the industry events have been delayed. This webinar forms part of our digital strategy to continue reaching out to our customers and share the latest technology updates. A full schedule of our upcoming digital events is available on our website, octio.com. All right, so just to set the scene, and so for today, a quick look at the agenda and the outline. Today's webinar will focus mainly on the technology introduction and the key applications and value proposition. In addition to that, we will spend a few minutes to look at the operational requirements and the footprint when it comes to the Drillwatch system offshore. We aim to have this webinar for 45 minutes, so we'll have 25 minutes for presentation and 15 to 20 minutes for Q&A. I would like to highlight that we have a follow-up webinar coming on 17th of November, and I do look forward to seeing most of you there. During that webinar, we intend to go through more technical details and recent case studies for OCTIO Gratitude. Again, a full list of events is available on our website, octio.com. And we are really excited to get some feedback from you. So if you have any questions, please type in the chat box button available with the webinar, and we will try to go through as many of them today as possible. If we are unable to answer any of the questions, we'll follow up and come back to you in the upcoming days. And finally, please don't worry about taking notes. We will make the slides and the video available on the company website, and we'll share the link. All right, so time to introduce my co-presenter, Jon-Ivan Lingard. Jon is geophysics by background and has extensive experience with OCTIO Gratitude and has done multiple management roles. He has been sick yesterday a little bit, so Jon, how are you doing today?
Thank you very much. I'm feeling much better.
Oh, that's good to hear.
It's great to be here and start the webinar series.
Yeah, so yeah, it's exciting time. This is one of our first webinars at OCTIO Gratitude, so we're really excited. All right, so let's get the ball rolling, right? So as many of you know, when we talk about OCTIO Gratitude, we're talking about a small company, but with industry-leading expertise, both in gravimetry and microseismic monitoring for reservoir management. We have two clear business units. On the left-hand side, we have the Gratitude side of the business with two key product offerings. G-Watch, which provides 4D gravity-based measurements sensitive to mass changes within the reservoir. And the second one is Depth Watch, which gives us the idea of the seafloor subsidence due to the pressure changes within the reservoir. Combining both these measurements together, what we really get is a time-lapse change in the reservoir properties, and it helps us to get very similar information than what we get from a 4D seismic service. But the key differentiator here is you get the same value at 1/10 of the cost, and with very little logistics. On the right-hand side is the second part of our business, which is the OCTIO, with two key product offerings. The first one is WellWatch. Here we are talking about long-term passive seismic monitoring, which is mainly focused on injection surveillance to enhance the recovery as well as safety for the field. And the focus for today is Drillwatch, which is basically real-time seismic monitoring for efficient and safer drilling using drill bit as an active seismic source. So when we talk about Drillwatch, what we really need is two things. One is the drilling bit, which is generating noise and acts as a source. And the second is the seismic cable prelayed on the seabed, which is the receiver. So these are the two components when we talk about Drillwatch. Now, when the bit is drilling, it's generating a continuous wave field. And there are two different ways we are focusing on this wave field. One part of the wave field is coming directly from the bit. And this is the wave field which we're using to position the bit. At the same time, there is some wave field which is going forward into the formations and getting reflected from the formations ahead or below the bit. And we use this wave field to get the information to look ahead of the bit. I would like you to have a kind of a quick snapshot in your head for these two photographs, because we'll be referring back to these photographs in the rest of the presentation. But before we go into more technical details, right? So the question comes, why Drillwatch? What is so different? So I would like to spend a minute explaining that. The first and foremost, Drillwatch is cost effective. Just for the fact, because you are not adding any tools in the BHA, that means you're not slowing down the operations, and you're not waiting for the weather, or you don't need a dedicated run to run Drillwatch. There is no tools in the wellbore. You don't interrupt the operations. Most of the time, you will not even notice. It's completely seamless. Secondly, this is the only technology in the industry which provides you 24/7 monitoring from spud to TD. This is a well-based monitoring, not a run-based or a section-based. So we prelay the cable and we hook it back to our system and we start monitoring, and we continue monitoring till we switch it off. And finally, everything is happening in real time. We have the capability to process and present results in real time offshore. And if we have a good connection to down, if it's a fiber, we can do all the processing onshore and present results. In addition to that, I would like to highlight that our software is hardware independent. And this can really help the customers who have already PRMs or loft system placed in the field. So as of now, PRM or the loft systems are used maybe 2 months a year based on the 4D seismic acquisition plans. But with our technology, we can enhance the value proposition of those expensive infrastructure which you have already placed, because we can use that to monitor drill bit positioning, look ahead imaging, as well as continuous passive monitoring. With that, I will focus on the key applications and the value proposition for Drillwatch. And the first one is drill bit positioning. Here we are focusing at the wave field, which is directly coming from the bit to the sensors. Now, as the drill bit is drilling, it's continuously generating sound. The challenge with that, it has a very low signal to noise ratio because there is a lot of drilling noise. So what we do is we look at this information and then we kind of stack it over a period of 2 minutes or 4 minutes based on the depth and the field we're drilling. And basically we correlate with the pilot source, and that helps us to improve the signal to noise ratio. So I put an example here for a common drill bit source gather for my real job, where we can see that after denoising and pilot correlation and stacking over a 2 minute period, we have a very good, very clear signs for the source output. At the same time, we have plotted the common receiver gather, which is basically different nodes on the seabed. On the top is the blue is the ROP. And the key message here is you can see when the ROP goes flat, the signal also dies, which helps us to show or demonstrate that we are mainly observing the noise from the drilling period, because when there is no drilling, we see signal going flat. We run this information through our proprietary software, and the output what we get is presented here. Basically, we can have a drill bit position accurate within few meters. And the biggest, there are two key differentiators I would like to highlight here. So one thing is we can provide a lateral positioning down to 2 to 3 meters of accuracy. There is no other technology in the market which can do that. Secondly, most of the conventional technologies like gyro well drilling, gyros, or MWD, the ellipses of uncertainty grows as you increase the step out. But in case of Drillwatch, the uncertainty stays more or less the same. So this can really help us a lot when it comes to brownfield development when you want to place well next to each other. That can really help a lot. In addition to that, we are providing a real-time measurement with maybe 2 meters of lag. So we are actually telling you position of the bit with 2 to 3 meters of lag. There is no technology in the market which can do that. As of now, all the conventional technologies based on the position of the sensor for MWD or gyro, the depth lag could be 15 to 20 meters. And this could be really, really critical when it comes to anti-collision. So these are the two key differentiators I would like you to keep in mind when we think about drill watch for drill bit positioning application. So this technology is mainly focused on the development assets. And when we talk about value proposition for our customers, the biggest one is this technology can help to increase field productivity. This could be by very active 3D steering for infill targets, as well as helping us to place additional wells in a brownfield where conventional technologies cannot help us to put the wells because of the ellipses of uncertainty. In addition to that, this technology can significantly reduce the well collision risk by positioning the bit, and it's independent of any casing interference. And finally, with this, you can reduce the tools, especially if you're using gyro well drilling in the BHA, which makes the BHA more complex. You can reduce those tools, and that reduces not only your drilling risk, it improves your drilling efficiency as well as reduces your lost in hole exposure. Now we'll focus on the second key application for Drillwatch, which is look-ahead imaging. So this is the seismic output which we get the same seismic output for bit positioning. So when we were working on the bit positioning, we were mainly focused on the signals which were coming directly from the bit, highlighted green, with a negative slope. Because as you're going deeper, it's taking longer for the signal to come back. So that's why you have a negative slope. At the same time, we realized that there is a lot of information from the reflections ahead of the bit, highlighted by red. So for look-ahead imaging, we focus on this information, which is coming from the formations ahead of the bit. And we pass it through the normal VSP processing, and we filter out the green information, and we focus mainly on the red. And what we get in the end is a reverse VSP corridor. And the key value here is this can be used to give you a very good reverse VSP. And as you can see here, this is one of the real cases which we did with one of the customers, that we have a much better resolution compared to a surface seismic. So we use this to eliminate any formations or geo-objects ahead of the bit, and can be fantastic for fault detection, for horizons, or any cross detection. And we will go into detail. So this one has a huge application both for exploration as well as development. So when it comes to value proposition, it has a huge exploration value proposition because it can be used to identify any faults or hazardous intervals coming ahead of the bit, especially in the field where you have a high uncertainty as per the NORSOC requirement. Most of the time you have to stop 2 times the uncertainty. And that can potentially result in adding additional casings. With this technology, you can reduce an uncertainty to maybe down to single-digit meters. And that can help us to eliminate few casing points. And once you eliminate casing, you're not only saving on the rig time, you're saving on the casing, you're saving on cementing, you're saving on mud. It's a huge saving. In addition to that, normally when we go to exploration, we start slowing down much earlier because of the risk of losses and before you enter the zone. But with this, as we have a good idea where the loss interval or the fault is coming, we can drill quite fast and only slow down in the last few meters. So that can really help us to improve the efficiency. And we're going to test this technology with one of our customers at the end of this year, where we're going to do it an exploration well around 4,000 meter TVD. So we are hoping that next year we can present the results for that. On the development side, there is a huge value proposition if you're drilling a geological pilot. Means if we are drilling only pilot for landing with conventional technologies, there is so much correction you can do in the last few meters when you're landing. And if your formation come more than few meters top, you end up converting that into a geological pilot or drilling a sidetrack. So this technology perfectly complements the conventional well placement technologies, where you have a very good control, much higher before you reach the formation top. So you can adjust your trajectory and do the final landing with the conventional technology. In addition to that, we can improve the reservoir drainage by placing wells close to each other, as well as targeting all the small reservoir pockets with this technology. And finally, similar to exploration, it helps us to reduce tools from the BHA, as well as improve operational efficiency, because you don't need to slow down early once you have a good control what's coming ahead of the bit. As we are in a stage, we are going towards commercialization of this technology. We have kept a very conservative number of 200 meters ahead of the bit. We do already have a case where we can see 1500 meter ahead of the bit. And we are in process of getting that data released, and hopefully we will see most of you in the next webinar on 17th of November, where we will present the results from that case study. Finally, we are kind of looking into the last main application for Drillwatch. So as I initially mentioned, this is the system which provides you continuous monitoring from spud to TD. That means we are not only monitoring during active drilling, we are monitoring also during any passive microseismic events happening. And that can help us to monitor well integrity if there is any acoustic sound coming due to the losses or anything. In addition, we can help to identify the perforation shots, or if there is an injection happening, we can monitor the injections, which we are doing with Equinor over the last 5 years. The biggest value proposition is this is coming at zero incremental cost for you, because we already have the system in place and we are monitoring it. So this really enhances the value proposition for the customers. And especially if you have a PRM in place and there is no requirement for hardware, we can just look at the data and start monitoring. Now we kind of will spend few minutes on the operational side to just give a sneak peek. What does the operations look like and what would be the footprint? So this is a very simplistic layout for the Drillwatch. Just a disclaimer, we do not provide the rig. I'm working to remove OCTIO signs from the rig. So we prelay the cable with the supply vessel on the seabed, and we just need vessel for 24 to 48 hours, and then we don't need the vessel. In addition to that, we do not have a dedicated vessel requirement, and we can use the supply vessel available with the rig, or if you are using a semi-sub and you're gonna prelay the anchors, we can use the anchor handling vessel. And the cable is tied back to the rig through an umbilical, which has the same strength as the sensor cable, and which I forgot to mention, are pretty much rated to 25 years of life. So these are very robust cables, and they are the same as what is used in 4D seismic acquisition when it comes to strength. And we need a 16-feet container on the rig where we have all our acquisition and processing hardware. And that's pretty much it, all the footprint we have. So if I have to quickly summarize the operational points, so on the right-hand side is the actual photograph, how the cable looks like. So this is just rolled on a drum, very, very robust system. As of now, we have 2 sensor setups ready, which we are using. We have a 100-node system, and we have a 240 sensor station system. And the sensors are 25 meters spaced. And with 240 nodes, that puts us like 6 kilometer length. In addition to that, we have the capability to run 2 seismic cables in tandem, basically 480 sensor stations or 12 kilometers. And that can help us to monitor multiple wells. If you're drilling multiple wells within a certain area, we don't need to deploy and redeploy the cables. In addition to that, there is no requirement to trench these cables. We just prelay these cables on the seabed and that's it. There is no requirement for trenching. Based on case to case, we can provide an on-demand system and we can turn it around within few months. It's fairly quick if they're based on the customer needs. But we have few systems already ready, and if needed, we can turn around a new system within few months. As like everything is in Norway, it's a NORSEC approved system. It's very ruggedized and we have optimized our multiple iteration that we do not need any dedicated vessel. So we can use the supply vessel. We have a special cable prelaying system, which can be just welded and we can prelay the system. Also, I would like to highlight something very critical. So as a company, we are focusing more and more on the software development. We have the industry leading hardware, but what we are really focused on to make the software automated as well as hardware independent. And as of now, our software is completely independent of the hardware. That means we can just plug and play with a PRM or a loft system. In addition to that, we are working to integrate our workflows with the customer workflows so that we can sit together with the customer and are involved in the decision-making process. With that, we are coming quite close to the end of this session. So if I have to summarize quickly, why Drillwatch? There are three key main factors. Drillwatch can help our customers to increase or improve oil recovery. This could be through well landing or placement, or could be targeting multiple reservoir pockets, or could be placing additional wells in brownfields where you cannot put more wells with the conventional technologies to drain the last oil. In addition to that, Drillwatch helps you to reduce the operational cost. This could be on exploration setting, could be improving the drilling efficiency or improving the optimizing the casing points, or on the development side, avoiding pilot holes. In addition to that, unlike the conventional seismic technologies like wireline VSP or seismic well drilling, as we do not have an external source, we are not weather dependent. So we don't stop the operations. And finally, as we are monitoring from beginning till end, from spud till TD, we help our customers to reduce the risk when it comes to wellbore monitoring. And also we simplify the BHAs that helps us to reduce the risks of lost in hole. So to conclude this session today, so we have come to a stage where we have a commercial technology ready to deploy. And we need the help from the customers to bring this faster to the market. And that's one of the reasons we are focused very much on building long-term relationships with our customers. And we are very flexible on the business models. Some of them we have done it with some of the customers in North Sea. We are very flexible so we can enhance the value proposition. Like if you have a big campaign and the cable needs to be there in the field for some time, we can work a solution which works for both sides. So the key focus for us is to build a long-term strategic partnership where we deliver value to the customer and we get help to develop the technology further. And we do have a good history of collaboration and delivering in North Sea. We have done operations with Wisting with our cable, as well as we have done studies and monitoring with Equinor, as well as ConocoPhillips and Aker BP. And at the end of the year, we're going to have a full real-time job with the OCTIO cable with one customer for monitoring and exploration well at 4,000 meter TVD. So we are going forward and we need your help to kind of make that jump so we can take this technology forward in the market. With that, I will stop the session or the talk from my side, and it will be really good to hear some questions and feedback from your side. So So please type the questions in the chat box. Any questions or comments from your side, please. There is a chat box option, Q&A. Please type the questions and we'll try our best to answer them today and give feedback if we cannot provide today in the upcoming days.
And while we're waiting, just want to say that so as Rajan already mentioned, this will be the first introduction webinar, and as already mentioned, we have a next where we will go a bit more into geophysical details, and this is coming up in mid-November. And again, you can find the details on our webpage. So if you go to our webpage and under events, it's possible to sign up for this webinar.